Today, I'd like to share with you the basics of how to be able to draw super artistic animations like these. This one actually is the code to draw this actually is this long, only about 10, 15 lines. It's pretty amazing. This is from an artist from Twitter, but I have, I'm trying to learn the basics of it and I will actually show you that we can actually create some interesting animations just using simple trigonometric functions, loops, using P5.JS, such as these. And we'll start simple and I'll try to give you the basics because I'm still learning. By the way, this artwork is, I have actually modified the original person's artwork and generated this. And this was the formula. This is by this person right here, Yuri. This is their X profile, and they have quite a lot of really interesting examples. Like, look at this. I mean, it really brings trigonometry to life because these are all done by using trigonometric expressions. As you can see, like this is a very simple demo of just rotating dots, and it just uses cosine and sine waves or functions to actually create this rotating motion. And the things that I've learned, okay, first of all, the interesting thing is that you can give any one of these to a cursor, even with just grok code fast, and let it explain it to you. And actually, you can just ask it to modify it, and you can modify it yourself. Now, we are using P5.JS for this, and P5.JS already comes with functions you call such as setup. This is the setup on the size, for example, and draw function. So you may get confused. Well, when you look at this, you don't call this draw anywhere in the code because P5.JS automatically does it on page load. And you set some time. Time determines the tick of time. For example, we can slow it down or speed it up greatly. We can actually speed it up quite fast. Like, look at this. And we can draw multiple points. Let's actually do that. I can bring in another point, and you can do quite a lot of cool stuff, like even just by changing time. Let's do 2, 3. So quite a lot of interesting things start happening, even with something super simple. And here we have time, and this time goes into the cosine, like x. If you maybe this will inspire you to study some trigonometry. I'm currently studying calculus. And trigonometry is not something that I actually enjoy, but this art stuff actually gives me more intuition about it. Because sine and cosine actually draws a circle. This as this time ticks, then the cosine actually finds itself at a different place in the unit circle, and so that is where the dot is drawn. And this additional number is the offset. For example, this is x1 and y1 are the location, the coordinate, the points in the coordinate system where these dots are going to appear. If you change this, then you can actually see we just offsetted one of them. Maybe if you slow it down, you'll be able to see better. See, we just offset this by 100 from the center. And this next one is actually the radius. For example, we can make this 300, and now it's going on a larger radius. So you can do quite a lot with just this. Let me actually get rid of the two and just leave one of them. And the code files for this will be available at my Patreon, by the way. Link will be in the description or in the comment, depending on where you're watching this from. And while you're there, consider becoming a paid member and have access to over 500 large language model powered applications and also weekly meetings. I also offer consulting services. Take a look at that membership as well if you're interested in talking with me or if you need help with your projects. Okay, so here we have another demo where this is the same thing where multiple circles are rotating, again using cosine and sine. As you can see, they are rotating at different speeds because of the fact that how fast the time is being passed, and it's actually being divided here. For example, here, if we divide this with 10, let's see if let's do both sides with 10. I believe this should slow it down. I'm still actually learning about this, but as you can see, each one, like you see this, one of them has negative time. That means I think it is going in the opposite direction. Now they're all going in the same direction. Yeah, so you can start simple like this, and then the way you start creating more interesting shapes is actually by combining. As you can see, this one uses sine and cosine, but it also uses hypotenuse, which actually determines the distance. So I can pretend to tell you that I actually understand this, but you can still play around with some of these variables. Like, for example, let's bump this up to 890 or 1090, and you can see the differences that it makes. Or let's actually bring it down to 79, and now they are much more dispersed. And yeah, you can actually play around with this. Really cool stuff. And the way I actually copied this into here is by asking cursor to copy the code that was present in the post. So if you see something like that on X, you can definitely ask it to implement it in Next.js. But let's take a look at the loop example. Here, so we go through a loop and draw a dot. Each like the loop variable of here 500 represents each dot. Like if you reduce it to 5, then we're only drawing 5 dots, then 50. And the way that each dot is drawn is depending on how we are modifying the angle and the radius. Like let's put this to 500. First of all, you can change the time variable, right? Slow it down or speed it up, and get different effects. Secondly, you can change the your loop maximum variable. The thing is that the reason why this loop doesn't stop is because P5.JS keeps calling this draw again and again. So, for example, let's play around with the angle. We can put the angle to 1 and we get a spiral. If we put it to 0.1 and we get a smaller or a less dense spiral. So this is a 5. This is a 4. Let's do 4, 5, 6, like 7, 8, 9. Or let's do 1, 2, 3. This one is 4, 5. So you get really interesting looking shapes. And this is the radius. We can reduce the radius or increase it greatly. Let's set this to 50 or 0, maybe 0.5. Yeah. And there's also the flower petals. We can play around with that too. Maybe comment this out. And there is more angles and stuff here. For example, let's move the petal. I think this is how many petals are going to appear. Okay. And then we define each one of the petals, and these are then there's a loop within a loop, and this one defines the how many dots we're going to have and the petal angle. So you can play around with the angle, and you get different results. Like this is 2, this is 3, this is 4, 5. Actually, 3 was kind of cool. And then here's the local angle. This is with 3. This is with 50. What was the original? Let's leave it at 50, and then the radius. And we can increase the radius as well. And then here the x and y coordinates are determined again with cosine and sine. Let's go back and bring back the. Yeah, this one looks good. Yeah, very interesting stuff. Maybe I'll comment this out and just leave the spiral. Yeah. I'm still learning, and I'm just taking my time, trying to understand and grow in intuition on how this all works. Hopefully, to work my way up to these types of beautiful animations. I think this will be a good learning experience. I just wanted to share this with you. Hope you'll enjoy it. Thank you. Let me know what you think.